So, good evening, everyone. Welcome to this lecture. In this class, we were dealing in the previous class. We were dealing with Young's double slit experiment. Yes or no?
Yes, sir.
We were dealing with certain questions, and I told you all the question will just come from the same concept. The important point that you have written: what is the fringe weight? What is the distance of this fringe from the center, what is the distance of that fringe from the center. All questions are centered upon those. We'll start with a question and then we will probably wind off this chapter. Let us see. Okay, let me give you this one because it has something that we have done. So this is the next question and it comes on your screen now. A double slit, that means a Young's double slit, is illuminated by light of wavelength 6000 Armstrong unit. The slits are 0.1 centimeter apart and the screen is placed at 1 meter away. This is normally how the questions are. The slits are only 1 or 2 or zero point 0.1 or 0.2 centimeters or millimeter apart. The distance of the screen is normally 1 meter, so that the calculations are simpler. What is the angular position of the 10th maxima in radian? What is the separation between two adjacent minima? I'll give you 2 minutes to do this. Yes, my dear friends. Yes, they're asking the angular position. Do we remember angular position? Anyone remembers angular position? Anyone remembers angular position? They're asking the angular position of 10th maximum. Yes, do you have an answer? Or shall I wait more?
Mains, sir.
Okay. Shall I do it?
Yes, sir.
When they're asking you the position of 10th maximum, basically they are asking you the angular width, the angle alpha of the 10th maximum. So angle alpha for the central one is lambda by d, small d. Yes or no? That is the angular position. Yes or no?
Yes, sir.
You have to find it for the 10th. You just multiply it by 10 and you get it. Do we understand this?
Yes, sir.
10 times lambda by d, that is the angular position. I hope you understand this. Yes or no? No, yes.
Yes,
Next
sir.
thing is separation between two adjacent minima. So I can go ahead with this and find out. So it will be 10 into lambda is 6,000. Armstrong unit is 10 raised to the power minus 10 divided by 0.1 centimeter, 10 raised to the power minus 2. You can divide this and you can get the answer. I hope you understand this. Yes or no? To find the separation between two adjacent minima or two adjacent maxima, they're asking you the fringe width. Yes or no?
Yes, sir.
They're asking you the fringe width. So if they're asking you the fringe width, tell them the fringe width lambda d by small d. Lambda is 6,000 into 10 raised to the power minus 10 into d is 1 divided by small d is 0.1 into 10 raised to the power minus 2. That is the answer that we are looking there. We got this, yes or no?
Yes,
Pakka?
yes, sir.
Can I give you one more?
Yes, sir.
Anyone has noted this one?
Yes, sir.
Then comes this question. In Young's double slit experiment, interference experiment, the distance between the two sources is 0.1 divided by pi mm. The distance of the screen from the source is 25 centimeters. Wavelength of the light used is 5,000 Armstrong unit. Then what is the angular position of the first dark fringe? First dark fringe. First dark fringe angular position. We have done one question of bright. Now this is the question of dark. Remember bright and dark. Remember bright and dark. How did we find out the position of bright and dark? Bright and dark. See here, bright and dark. This one is bright. This one is dark. You have to find the angular position of the first dark fringe. Yes, beta, get the answer. So you can take a note. Angular position for the bright fringe. The nth bright fringe is n lambda by small d. That is the angular position. For net bright fringe, for net dark fringe, how will you find it out? 2
n minus 1 by lambda by
2m minus 1 lambda by 2d. Do you understand this?
Yes, sir.
So just put the value of m as 1 and you will get the answer. 2 minus 1 is 1. So it will be lambda by 2d. That is the answer that we are looking at. I hope everyone understands this. Yes or no?
Yes, sir.
Please note it down and I'll get you the next question.
Completed, sir.
And the next question is this one. In Young's double slit experiment, the two slits are illuminated by light of wavelength 5890 Armstrong unit, and the distance between the fringes is 0.2. The whole apparatus is immersed in water. Then find the angular fringe width. Angular fringe width. The entire apparatus is in water. Remember that, beta.
Sir, 467.5.
Yes, bacha? Angular fringe width is
607.5.
okay. I'm not able to hear your voice. In Young's double slit experiment, the two slits are illuminated, and the distance between the fringes obtained on the screen.
Sir, 88.35.
88.35. I don't know what you're talking about. 88.35. What are you getting? Let me see. The distance between the fringes obtained. So what is given here? What is given here?
Wavelength.
0.2 is the wavelength. Sure. 0.2 is the wavelength. Distance between the fringes obtained. What do you mean by that?
Beta.
Yeah, beta is given to you. The whole apparatus is dipped in water. So beta is given to you is 0.2 solution. Beta, the fringe width is given to you, right? So in the first case, beta is given as 0.2. Now, if we talk about theta, it is beta divided by d. Yes or no? Right?
Yes.
Now, d, the distance between the slit and the screen will remain same. What is going to happen? That means theta is directly proportional to beta, right? And when we talk about beta, we find out the beta in air. What is beta in air? So it will be given as 0.2. That
Divided by water.
yes, beta. If we divide this beta by d, we will get the value of alpha. Yes or no?
Yes.
Yes, sir.
Alpha in air. Okay, this is alpha in air. Now, how do I get alpha in water? Alpha in water will be beta in water divided by d. Yes or no?
Yes, sir.
Now, what will be beta in water? It will be beta in air divided by mu. Yes or no?
Yes, sir.
That's it. Now you look at here. Beta in air divided by d. That is your alpha. Yes or no? So your alpha for water will be alpha in air divided by mu. Do we understand this? So that is the result that we are looking at. So basically what we got to see here is when you dip the apparatus in any medium, lambda in the medium becomes lambda in air divided by mu. Beta in the medium becomes beta divided by mu. And alpha in the medium also becomes alpha divided by mu. Do we get this?
Yes, sir.
Now, here, beta in air, you can find out beta in air. Yes or no? You can find out alpha. Alpha in air will be 0.2 divided by 5890 into 10 raised to the power minus 10. From there, you can get the value of alpha in air. To get the value of alpha in medium, you just divide it by mu. Do we understand this?
Yes,
Yes,
sir.
sir.
Everyone?
Yes, sir.
Okay, so basically you got to remember these three relations. That is the summary of this entire exercise. I'll give you 2 minutes to note this down. Have you noted it down, everyone, bacha?
No, sir.
Okay, I'll wait, sir.
Completed, sir.
Completed, sir? Everyone, sir? Then comes the last part of this is displacement of fringes. What do you mean by displacement of fringes? Up till now, what was happening was you had two slits, waves were interfering from those two slits at this point P. Now, what I have done is you can cover one of the slits. The way this question is asked is one of the slits is covered with a glass slab. You can see this glass slab. The thickness of the glass slab is T and the refractive index is mu. So the slit is covered, or you place a slit, or you place a slab, not slit, slab in the way of slit number 1, which is the top one, or you can do it for slit number 2, which is bottom one, or you can place a slit in front of one and also in front of two. Now, because of this, what happens? We have already seen the optical path and the geometrical path. When light travels in some other medium, its speed becomes v divided by mu. The time that the the time that the light remains in that medium, in the same time it can travel a different distance in vacuum. That is known as the geometrical path and the optical path. Yes or no? Do we remember that? We have given you some questions in the test as well based on geometrical path and the optical path. Now, what is going to happen is because of this is the path difference between the two waves S1P. Previously, it was S2P minus S1P. Now, in the way of S1P, there has a glass slab has come. Therefore, the path difference will change and therefore the fringe will shift. So that is the first point that you must understand. Fringes will shift. Now, once we understand that the fringes will shift, then we have to understand in which direction will the fringes shift. Now, normally you will have the central bright fringe coming at point C, but if you place a glass slab, fringes will shift. Fringes will shift in the direction of slit. What do I mean by this? If I place a slit in front of the upper why I'm saying slit, if I place a glass slab in front of the upper slit, the fringes will shift upwards. So in this case, fringes will shift upwards. If I put a glass slab in front of the lower slit, then they will shift downwards. If I put glass slab in front of both of the slits, because of the upper slit, why I'm saying slit, because of the upper slab it will shift in the upward direction, because of the lower slab it will shift in the lower direction. Do we understand this? The difference, you have to understand how much is the shift. So you just have to remember this formula. The shift is capital D by small d into mu minus 1 times t. Capital D is the distance between the screen and the slits. Small d is the distance between the slits. Mu is the refractive index of the glass slab and T is the thickness of the glass slab. You can also write it beta, which is the fringe width, divided by lambda into mu minus 1 times T. Remember, if the upper slit is covered, it will shift upwards. If the lower slit is covered, it will shift lower. If both the slits are covered, because of the upper slab, it will shift upwards. Because of the lower slab, it will shift downwards. Do we understand this? I'll give you 2 minutes to note this down. Remember in what direction it shifts and how much is the shift. That these are the two things that you should remember here. the direction where it shifts, and the amount which it shifts. Normally, there you can also write one more formula that I mean, it's better to write it rather than to derive it, because in derivation, they might sometimes tell you how many fringes are shifted. The shift due to glass slab is equal to 5 fringes or 6 fringes. From there, you can find out the value of T. Total shift is beta by lambda into mu minus 3. Therefore, you can write number of fringes shifted. It's just a mathematical calculation. Number of fringes shifted, let us call this as N, will be equal to shift divided by beta. If you divide shift by beta, you will have mu minus 1 times T divided by lambda. Are you getting my point, bacha?
Yes, sir.
Sometimes they give you the number of fringes shifted is 5. From there, you can find out either mu or T or lambda. Normally, they will ask you T, what is the thickness of the slab. So the formula for T becomes N lambda upon mu minus 1. Do we understand this? Yes or no? No, yes.
Yes, sir.
I'll give you 2 minutes to note this down.
Completed, sir.
So quickly? Well done.
No, sir.
Okay, I shall wait. Let us all go in it together.
Hold on.
Done, beta?
Done, sir.
Done, sir.
Okay, I'm looking for a question. Okay, I did not get a simple one. The only ones that I'm getting, I have a simple one that consists of one slit. Okay, so I'll give you this one first, then I will go ahead with the next one, which shall settle this case forever. So this is the question. Thankfully, we got this. Again, this is a question that has come in previous NEET as well as previous year JEE. So this is a question, and this is how questions are framed. A thin mica sheet of thickness 2 into 10 to the power minus 6 meters and refractive index mu 1.5 is introduced in the path of the first wave with the upper wave. The wavelength of the wave used is 5000 Armstrong unit. The central bright maximum, they can ask you central bright maximum, they can ask you first maximum, second maximum, first minimum, second minimum, doesn't matter. The central bright maximum will shift how many? Will it shift upwards or will it shift downwards? Upwards or downwards? First slit.
Upwards, sir.
Upwards, sir. Give me the answer, sir. Do we have anything that looks like an answer?
10 fringes upwards.
10 fringes upwards. That is the answer that you're getting. Huh?
2 fringes upwards, sir.
2 fringes upwards. That is the correct answer. How did you get 10, bacha? There's no way you can get 10. How can you get 10? Huh? And all I've given you everything, yeah. I've given you everything in the form of a formula that you can apply this. See, you just have to apply this formula. Which one? This pink one. Yes or no? Number of fringes that are shifted. Yes or no? Mu minus 1 into t divided by lambda. Put the value, get the answer, and stay happy. You must always stay happy in your life, no matter what you are doing. So what formula I need to apply? Straightforward. Number of fringes shifted is mu minus 1 times t divided by what? D or lambda? Divided by lambda. Yes or no? Huh?
Yes, sir.
Mu is 1.5. T is this thing. Lambda is this thing. You can calculate and you will get the number. How many number? What number are you getting? 2 or no?
2 fringes upward, sir.
2 fringes upward, sir. Well done, sir. Comes a question that has come in JEE. JEE. Are we ready for the JEE one?
Yes, sir.
Chalo. The question in the JEE was actually I will try to get that question as well, the actual language of the question, but anyways, you can do this, not a problem. Yes. Question number 3. In a YDSE experiment, D is this. I told you in all experiment, D is 1 mm and capital D is 1 meter. Thickness of slab 1 micrometer. Mu 3. Thickness of second slab 0.5 micrometer introduced. So one is in the upper, the second one is in the lower. Find the shift in the interference pattern. I'll give you 2 minutes to solve this.
Sir, 1.5.
The answer is 1.5 mm. Are you getting it?
Yes, sir.
Well done. That is the correct answer. That is the correct answer. Well done. Everyone got this? So, how are you supposed to do this? Let us say how much will it shift upwards. So upward is this one. So to let me write the full thing. Shift upwards. Mu minus 1, mu1 minus 1 into T1 beta by lambda. Yes or no? But here beta and lambda are not given to us. So what is given to us is capital D by small d. So I should not use beta by lambda. I must use capital D by small d. I can put the values. Mu1 is equal to 3. T1 is 1 micrometer. Remember the signs. D and D are 1 and 1. So it will not have one is 1 meter and one is other mm. So how much is the shift coming upwards? Can anyone tell me by calculation? How much is coming? 0.5?
Yes.
Okay, I can't hear you. Anyways, I hope you can calculate this. I know there's something that you should do on your own, because otherwise you will not get confidence. Shift downwards will be equal to mu2 minus 1 into T2 into D by D. Let me mark it. Mu2 is 2.2. T2 is 0.5 micrometer. From there, you will get the shift downwards. Now you can find out which shift is more, whether the shift upwards. I think upwards it is coming as 2 mm. Yes or no? And the downward shift is coming as 0.5 mm. So basically, it will shift upwards, and the net shift will be upwards, and it will be 1.5 mm. I hope everyone understands this. Yes or no? Okay. Let me present to you one more question on this, which I saw. This one. And I hope you can see this question. In a young double slit experiment, fringes are observed by using a light of wavelength 4800 Armstrong units. If a glass plate 1.5 is introduced in the path of one of the waves, and another glass plate is introduced in the path of other wave, one glass plate is having refractive index of 1.5, the other is having refractive index of 1.8. The central fringe takes the position of fifth bright fringe. What is the thickness of the plate? You have to imagine that both the plates are of equal thickness. Do you understand this? Both the plates are of equal thickness. The thickness is T. Both the plates are of equal thickness. Let's see who gets me the answer. I'll give you 2 minutes to solve this. Anyone got the answer? I'll give you time. Shall I do it? Shall I do it, beta?
Yes, sir.
Okay. How are you supposed to do this? Let us say the first plate is put in the upwards. So what is the shift in the upward direction? What is the shift in the upward direction? I can write it as mu. Mu is 1.5 minus 1 into T divided by lambda. Yes or no? Lambda is 4,800 into 10 to the power minus 10. Yes or no? No, yes.
Yes, sir.
Well done. Then I can find out shift downwards, my dear friends. 1.8 minus 1 into T divided by same wavelength 4800 into 10 to the power minus 10. See, try to avoid writing this every time. I have wasted a lot of time in writing this. I should not have written this. I should have just written it as lambda. So I would have saved a lot of time. Do we understand this, bacha? Don't write this. Only write the values in the final case. Okay. So it will shift more downwards. What is the next shift? You can find out the next shift. Next it will be 1.8 minus 1 minus 1.5 minus 1. So it will be simply 0.3. 0.3. Oh, I have not multiplied by beta. Sorry. Beta by lambda. Okay. 0.3. 0.3 T beta by lambda. Yes or no, my dear friends?
Yes,
Yes or
sir.
no? And that is nothing but The central shift has shifted to the fifth bright fringe. So central fringe has taken the position of fifth bright fringe. So what is the shift? It is 5 times beta, n times lambda, n times beta. Yes or no?
Yes, sir.
Beta getting cancelled. You can get the value of t. T will be equal to 5 lambda divided by 0.3. Do we understand this, bacha?
Yes, sir.
Everyone got this? So basically what we are looking at, beta, is when you introduce this glass slab or mica slab or whatever slab, fringes shift. Sometimes they ask you how much they shift. Sometimes they ask you how many numbers of fringes are shifted. Sometimes they tell you shifted this much, find out the value of this much. So these are the ways in which they ask you the question in the examination hall. Do we understand this?
Yes, sir.
Let me see if I can find any more question on this shifting. I think we have done all the questions that were possible. So that brings, let me see if it is here. If it is here, no, it's not here. We have done all the questions. So that takes us to an end of this part of wave optics. We are done with Young's double slit experiment. What all things we have seen? We have only seen one diagram, and remember that diagram. Do we remember this diagram? The original one.
Yes, sir.
Everything just happens with this diagram, beta. 3 diagrams you will have to remember. Diagram number 1, I will show it to you. A quick recap. Diagram number 1, capital D, small d, lambda. Diagram number 2, path difference for bright fringes n lambda. For dark fringes, 2m minus 1, 2m minus 1 lambda by 2. Destructive interference, constructive interference. Everything comes from these 2 or 3 points, nothing else. Do we understand this? Fringe width, distance of any bright fringe is n times beta. Distance of any dark fringe is 2m minus 1 times beta. We all understand this, yes or no?
Yes, sir.
Yes,
Then
sir.
angular fringe width, you can write it as beta by capital D, or you can write it as lambda by D. Whenever they ask you the angular position, they're asking you the angle. Do we understand this? Angle of bright will be n times, angle of dark will be 2m minus 1 lambda by 2 times. Do we understand this?
Yes, sir.
If you understand this, then
Yes, sir.
wave optics was first part and the major part is done. The next class we will move with diffraction, and I hope that we can do diffraction. The last class, third class, for by this weekend I am thinking of finishing your wave optics all together. So with that, I come to an end of this class. I hope you understood what we were doing. Take care. God bless you. If there's anything that is troubling you, please let me know. Bye bye for now.
Thank you, sir. Bye.